Operations with signed numbers. Integer is the name of positive and negative whole numbers. So when we're working with integers, we can think of it as the number line, where 0 is at the center and the numbers to the right are positive numbers. So our numbers here are positive, 1, 2, 3, and they go off indefinitely. Now positive numbers will not have a sign in front of it. So if there's no sign in front of the number, you know that it's a positive number. Negative numbers are to the left of 0 on the number line, and you will see a sign in front of the number. You will see a negative sign, or sometimes it's simply a minus sign. But negative and minus are the same thing. And this is my set of integers. So my set of integers consists of positive and negative numbers. A key note here is 0 is neither a positive nor a negative number. So we're going to first work with the double negative property. And what the double negative property is when you have a negative to a negative, what that's saying is, what is the opposite of a negative number? Well, the opposite of a negative number would be a positive. So whenever you see a double negative in a problem, it's either going to come out to be a positive value or you're going to change it to a plus, because a plus means that it's positive. Absolute value, we're going to be working with absolute value, and note here that the symbol for absolute values will be 2 bars. When we have an absolute value, it is simply the size of the number with or without the negative sign. So when we're taking the absolute value of a number, it is how far from 0 on the number line that number would be. So if I have the absolute value of a -7 and I have bars around the negative, that indicates that it's the absolute value. What I'm looking for is how far is -7 from 0 on the number line. And because a distance can never be 0, when we take the absolute value, it will come out as a positive. So the process is called evaluation of an absolute value. So when you're evaluating an absolute value, the number inside will come out as a positive. It also works when you're taking the absolute value of a positive number, that it will come out as a positive. So if you're looking for the distance of +7 from 0 to the number line, it will be a +7 when it comes out. So absolute values, when you're evaluating whether it's going to be a positive or negative number, to remove the absolute value symbols, those bars, when you take the number out, it comes out as a positive. So we're going to start off with the addition rules for signed numbers. When we're adding and they have the same sign, so if integers have the same sign, you're going to add the numbers and you're going to keep the same sign. So we're familiar with a positive plus a positive. 2 plus 2 equals 4. So a positive plus a positive will end up being a positive answer. But when we see a negative minus a negative or minus a number, really what we have is the same sign. They're both minuses signs, or they're both negatives. So you're going to end up adding the 2 numbers together, but you're going to still end up with a negative number. So when you add the 2 numbers together, your answer will be a negative answer. So we're familiar with something like this. We've seen this before. 5 plus 4. I know that 5 is a positive number because there's no sign in front of it. So really what I have here is a positive plus a positive, and I end up with 9 as my answer. And you're going to keep the sign, and remember, you never put a positive sign in front of a positive number. So there would be no sign if your answer ends up being positive. Now this is the case where it's a subtraction. You look at this and you think it's a subtraction problem, but because I have a -7 and I have -4, and negative and minus mean the same thing, I end up having two negatives here that I'm adding together. So when you have the same sign, you're going to add the two numbers together, and I don't want you to actually rewrite it with the addition sign. You should ideally be able to do a minus or a negative and a minus means I have to add the two numbers together, and I'm going to keep the sign. So I end up doing 7 plus 4, and I end up with 11, and because they're both negative, I end up with a -11. So now this is where you have to be careful, because it looks like subtraction, 8 minus, and then you have a -5. So this is where that double negative is going to come into play. Whenever you have a negative and then another negative, that negative will change to a positive. So when it changes to a positive and it's mixed into a problem, you need to make sure that you change it to a plus sign so that you know that you're adding it to anything that's there. So in this case, I end up having 8 plus 5. I add it together and I end up with a +13. Pause and try. So in this case, you see that it's a double negative. That double negative is going to change to a plus. And then you have 3 plus 6, so you end up with 9. Pause and try. So hopefully you see here we have the same sign, and that sign is a negative. So I end up adding the two numbers together, and I end up getting a -5 and keeping the sign. So now I want you to notice here that I have the absolute value symbols, and then I have an operation going on inside the bars. Well, in order to take the absolute value, you have to get whatever's inside to be one number. So you notice that inside I have that same sign. I have same sign, which means I have to add the two numbers together and keep the sign. So I end up having 9 plus 8, and 9 plus 8 is 17, and it's a -17. And now, because it's one number, I can evaluate the absolute value. And remember, whenever you have an absolute value of a number, whether it's negative or positive, it will always come out as a positive number. So in this case, the absolute value of a -17 will come out as a positive. Now notice this one. I have the absolute value symbol, and I have an operation inside, but I also have that negative sign on the outside of the absolute value. So you have to first work inside the absolute value. And inside, you notice we have the same sign, and that sign happens to be negatives. So I'm going to add the two numbers together and keep the negative sign. Now, in this case, you have to be really careful because there's a difference between the absolute value and parentheses, because this might look like a double negative, but a double negative uses parentheses to indicate it's a double negative. But in this case, it is the absolute value of a negative, and then on the outside I have a negative. So you have to first take the absolute value of the negative, and you end up with a positive, and then you apply that negative that's on the outside to your answer. So you end up, in this case, having a -12 as your answer. So you have to be very careful when you're evaluating absolute values. Pause and try. So notice here inside the absolute value, you had a double negative. You had to deal with that first. So that double negative changes to a plus. Now you're going to add the numbers inside, and then you're going to take the absolute value. The absolute value of a +23 will come out as a +23, and then you apply that negative that's on the outside of the absolute value. So your answer here would be a -23. Pause and try. So hopefully you see here, you have the same sign. You have the same sign, therefore you have to add and keep the sign, so you end up with a negative 29. Now that you have it as one number, you can evaluate the absolute value, and all absolute values come out as a positive. So your answer here would be a positive 29. The next adding rule for integers or any type of numbers is this. If you have different signs, if the signs in front of the numbers are different, meaning you have a positive number and you have a minus sign, well, you're going to subtract. So we're familiar with 3 minus 1 would be 2, but it's different if it was a negative 1 plus 3. You would see the two different signs. So different signs you're going to subtract and keep the sign of the bigger number. And that's really important when you're making the decision of what sign your answer would get. So if you have a bigger number is positive, well, your answer is going to be positive. So if you have 4 minus 2, you end up with 2 as a positive answer. But if you end up having the bigger number is negative, you have a 2 minus 4, well, your answer is going to end up being a negative answer. So it's really important to think about the rules when you're doing these operations. So in this example, you can clearly see I have two different signs. I have a negative 9 and I have a plus 4 or a positive 4. So in this case, you have different signs. And whenever you have different signs, you're always going to have to subtract. Now you can't subtract 9 from 4 because 4 is smaller than 9. So you're always going to have to subtract the way you subtract, the smaller from the larger. So in this case, I'm going to take 4 away from 9 and I'm going to get 5. And because my higher number has a negative sign, my answer is going to end up being a negative. So it's very important that you make that decision after you perform the operation. And in this case, I end up with a negative 5 as my solution. Now notice here, you might think that we have the same sign, but you have to deal with that double negative. So always take care of the double negative before you perform any operations. So double negative means that that's going to change to a plus. Now you have that different signs, and when you have different signs, remember you're going to subtract. So opposite signs, you subtract the smaller from the larger, and then you decide what sign that gets. And because the higher number in this case is a negative, my answer will end up being a negative answer. Pause and try. So you have that double negative, and now you see different signs. You're subtracting, and notice here, the higher number is positive, so your answer is going to be a positive answer. Pause and try. So in this case, different signs mean you're subtracting. You subtract and you get 5, and your higher number is the negative, so your answer is going to be a negative 5. Pause and try. You see the different signs here. You subtract, the higher number is positive, so your answer is going to be positive. Pause and try. You have that double negative. You have to be careful with that. Change it to a plus, positive, and then you have different signs, subtract, and keep the sign of the higher number. So now when you have multiple operations going on or multiple addition and subtraction problems, you want to take care of them from left to right. But before you do anything, you want to remove the parentheses. Now I want you to notice here, we're going to rewrite this problem so that there's no parentheses in it. And when you see the plus minus, a plus minus will turn into a minus. A plus minus will be a minus. Bring down that negative 3, and then notice here I have a double negative, a negative negative. So now that's going to change to a plus. So when you're working a multi-step problem like this, you want to make sure that you get rid of the parentheses first by following the rules. A plus minus will stay minus, A minus minus or double negative will change to a plus. Now you want to work from left to right. You always work from left to right when you're doing a mathematical problem. So when you look at this problem here, I want you to notice that I'm just dealing with the 7 minus 12. Now 7 doesn't have a sign with it, so you know it's going to be positive, which means I have different signs here. Different signs mean I subtract, and I keep the sign of the higher number. And the higher number is that minus 12 or negative 12. So it ends up being a negative 5. And now I'm just bringing down the minus 3 and the plus 8. And I'm still working from left to right. I see a negative 5 minus 3, same sign, so I'm going to add and keep the sign. I end up with a negative 8. And I'm bringing down that plus 8. And now I have a negative 8 plus 8, which is going to give me 0 here. So be careful when you're working a multi-step problem that you work from left to right, first removing the double parenthesis, or first removing the parentheses by following the rules. A plus minus will be a minus. A negative negative or double negative changes to a plus. Pause and try. So see here, I changed the signs and got rid of the parentheses. Double negative is a plus 7. A plus minus is going to be a minus 9. Working from left to right, negative 3 plus 7 is going to be a positive 4. And then I do 4 minus 9. I'm going to end up with a negative 5, taking the sign of the higher number. And then I have same sign. I'm going to add and keep the sign. So my answer here is a negative 17. So this next thing that we're going to work with is called evaluation. So when we talk about evaluation of algebraic expressions, I want to first define what a variable is. A variable represents an unknown value, and it's any letter of the alphabet can represent an unknown. So in this case, we see an algebraic expression, and it's an algebraic expression because we have numbers and we have letters. So the first thing you see is 4 plus x, which is a letter, or 5 attached to y. And when a number is attached to a variable, it means it's being multiplied to that variable. So we're going to work with the valuation or evaluating algebraic expressions. And what that means is you're going to find the value of the algebraic expression by substituting numbers in for the variables. Now we're going to be given numbers at first, but in the future you will be choosing numbers. So we want to evaluate the expression for the given value of the variable. So I have this expression 8 minus j, and it wants me to evaluate this expression where j would equal negative 6. So what you're going to do is you're going to take a negative 6 and you're going to replace the j with that negative 6. Now whenever I'm doing evaluation and I have a negative, I like to put the negative in parentheses before I plug it into the letter. So now you can clearly see we have a double negative. So I can evaluate this by dealing with that double negative, and then I can perform the operation. So in this case, I end up having 14 as my solution when j equals a negative 6. I want to show you this next example where I'm going to evaluate the expression where n equals a negative 2 when my expression is n minus 6. So I'm going to take a negative 2 and I'm going to plug it into n. And because n is the leading term, I'm just going to substitute it in without parentheses. But you should see here I have same sign, which means I'm going to add and I'm going to keep the sign. So I end up with a negative 8. Pause and try. So in this case, you should plug it in. You see that double negative changes to a plus, and then you add and you end up with 14. Pause and try. So when you plug in negative 9 here, you end up with same sign. You're going to add and keep the sign. So you should have gotten a negative 16. Pause and try. So notice here when you plug it in, you're going to get that double negative. That double negative is going to change to a positive, but now you have different signs. With different signs, you have to subtract and keep the sign of the higher number. So in this case, you should have gotten a -5 as your solution. So we're going to be working with word problems with integers. So a couple things to keep in mind when you're doing problem solving with integers is negative numbers or integers can be used to describe real world occurrences, such as measures temperature. 50 degrees below zero is a -50. Elevations below sea levels are considered negatives because you're going under the ground. To owe money is considered to be a negative. To withdraw money from your bank decreases your balance, therefore it's a negative. Depositing is adding money to your account, so that would be an add or a positive number. A business loses money, they are in the red. That is considered a negative. So if you lose money, it's a negative value. And this is all important information when we're doing problem solving with integers. So some clue words for addition. If you see in the word problem, it says in all together, sum, total. It means that we're adding things together. If you see some keywords, so how many more, how many are left, the difference, these words indicate that we're performing subtraction. So let's do an example here. Joe owes his brother $8 and finds $5 in his jean pocket. How much does he still owe his brother? So in this case, we see that Joe owes his brother $8, which means he's a -$8. He owes money. It is a negative value. But because he just found $5, he actually has $5 to give to his brother. So in this case, you'll see the O is the -8, and the finding of $5, add 5. And this is where the integer rules come into play. We have different signs, so that means that we are going to subtract, and we're going to keep the sign of the higher number. So in this case, he still owes his brother $3, so that would be a -3. Pause and try. So in this case, you see that the thermometer says that it's -5 degrees outside. The sun comes out, and the temperature went up, which means you're going to add 7 to that -5. How warm is it now? So in this case, you see different signs. So you're going to subtract, keep the sign of the higher number. So we end up with a +2 degrees. Pause and try. So in this case, you see that the temperature outside is a -12. And in the evening, the temperature drops, which means it's going to go again down or a negative. So we end up with a -12 minus 15. So you see we have same sign here. So we're going to add and keep the sign. So we end up with a -17 degrees. So now we have a word problem where there's a couple things going on. So Carol went mountain climbing and reached a mountaintop of 450 feet above sea level. On the same day, her sister Jill explored caves in an old, dried-up river valley. Jill was at an elevation of 150 feet below sea level. And these are key words that you want to know. How much higher was Carol than Jill? So what we do know is that there's a difference here between where Carol is and where Jill is. So that means that we're going to be subtracting. So we have 400 feet above sea level, and then we have Jill is below sea level, so she is down by 150 feet. So when we do this, we're subtracting the two from each other, but because the sea level is below the ground level, it's a negative value, and we're subtracting to find their difference, and this is where you're going to see a double negative in a word problem. So in this case, you see that double negative, and a double negative means I have to add the two together, and then I'm going to find their total difference. And keep in mind that if Carol's on the top of a mountain and Jill is below the sea level or below the mountain, that difference or that distance is going to be further than closer. Pause and try. So hopefully you see in this, the temperature is 5 degrees and the low temperature was a negative 15. The difference, and that's mean subtraction, we're going to end up subtracting the two. So 5 minus a negative 15, and that's going to give us that double negative. That double negative changes to a plus, and we end up with 20 degrees.